Alright everyone, gather round. Today we're diving into the world of Node.js performance. Picture this, a massive file, 1 billion rows of data. Our mission: process it as fast as humanly, or should I say computationally possible. This is the 1 billion row challenge, a true test of Node.js efficiency. We're talking raw speed, pushing the limits of what JavaScript can do. Buckle up, because this is going to get technical. But first, let's talk about why this matters. In an age of big data, efficient data processing is king. Whether you're crunching numbers for scientific research, analyzing user behavior for a web app, or just trying to get through a mountain of spreadsheets, every millisecond counts. Our weapon of choice, Node.js, the popular JavaScript runtime. It's known for its speed, but can it handle the heat of 1 billion rows? We started with a basic Node.js script. It read the file line by line, split each line into fields, and then did some basic processing on the data. Sounds simple, right? Well, not so fast. When we unleashed this script on our 1 billion row monster, the results were underwhelming. Processing time crawled along at a snail's pace. Clearly, we needed to optimize. But where do we begin? Enter Clinic.js Flame, our performance profiling tool. Think of it as a detective for your code, sniffing out bottlenecks and performance killers. Clinic.js Flame gave us a visual representation of our code's performance. It was like putting on X-ray vision and seeing exactly where our script was struggling. And boy was it struggling. The culprit, string prototype split. This innocent-looking function, responsible for splitting each line into fields, was eating up a huge chunk of our processing time. Why? Because we were calling it for every single row, 1 billion times. Talk about overkill. We needed a more efficient way to handle our data. Our first optimization was simple but effective. We reduced the number of string prototype split calls. Instead of splitting the entire line at once, we split it into chunks. This reduced the workload on string prototype split and gave us a noticeable performance boost. It was a step in the right direction, but we knew we could do better. We needed a more radical approach. It was time to bring out the big guns: byte-level processing. Section 5. The byte-level revolution. A giant leap for performance. Byte-level processing is like speaking the computer's language. Instead of dealing with strings, which are high-level abstractions, we work directly with bytes, the raw data that computers understand. We wrote a custom parser that iterated through the file byte by byte, extracting the data we needed without relying on string prototype split. This was more complex, but the performance gains were astonishing. Our script was now blazing through the data, leaving our initial